the voltage that is appeared at this point. This is, we used to call it V1, and we can call this current I0, and the voltage at this point is used to call V0. Okay, so what's to do? So what we are going to do over here is, like we already know. Okay, I am going to erase this because I got very limited space over here on the whiteboard, and next time I will be drawing a smaller circuit. I'm drawing it very large here. Anyway, the circuit diagram is the very same that you got on your textbook, so you can refer to that further. I would suggest you to have your textbook open while listening to these lectures in PDF format, maybe on your same screen or another screen, so that you can easily get back to what we were talking about, what was the circuit that we were talking about. Okay, the circuit we have discussed, we can say that V0 is equal to RF by R1 into V1, with obviously a negative sign would be there, and this V0 in this particular circuit, as you might remember, इधर मैं बना देता हूँ आपको वो सर्किट दोबारा से. This was our meter and this is our RS. So we can say that this V0 is equal to the current through RS, I0 into RS. So we can say this thing, we can replace this thing with I0 RS is equal to minus RF by R1 into V1. And since we are interested in the ratio of I0 and V1, because this is the applied voltage that we are measuring, and I0 is the current that will be flowing through the galvanometer. So we are not interested in absolute values of these things, instead we are interested in the ratio of these things. So what we will take is bring this V1 here and take this RS over there, so we will get I0 over RS is equal to RF by R1 into 1 by RS, and there will be a negative sign as well. So this is what we come up. This is the expression that we comes up. Okay, now what does this expression meant to us? That the circuit that is there in your book at page number 659, it says that R1 is 100 kilo ohms, RF is also 100 kilo ohms, and RS is 10 ohms. So this whole thing will be equal to 1 by 10, means that I0 over, sorry, it's not RS over here, it's V1. I0 over V1 is equal to 1 by 10, means that if there would be 10 volts, a current of 1 ampere will be flowing. If there would be 10 millivolts, a current of 1 milliampere will be flowing through the galvanometer. Now when you get the galvanometer, when you buy the galvanometer, it used to say the maximum deflection current. Let's say the galvanometer has maximum deflection current of 1 milliampere. In that case, applying 10 volts at 10 millivolts at the input will result in 1 milliampere current, and then 1 milliampere will give you a full scale deflection in the galvanometer. So your measuring range would be 0 to 10 millivolts, because if you measure 0, if you got 10 milliamperes, you will get 1 milliampere current, and that will be causing maximum deflection. If you got 5 volts, at the end, 5 millivolts at the input. Let me draw it over here. 0 volts, and this would be 10 millivolts, and here would be 5 millivolt. So this would be your scale. You apply 10 millivolts here, you will get 1 milliampere current, which will cause maximum deflection, that will be here. If you apply 5 millivolts current, that will cause half scale deflection, that would be here. And what if you want to increase the range? You want to measure tens of volts. Then what you need is, you need to put this resistor to be of 10 kilo ohm. 10 kilo ohm resistor, so that you will be getting 1 milliampere of current against 10 volts. बात समझ में आई? सादा मैथ है यार. आई एम श्योर आप लोगों को समझ आ गई होगी. इनफैक्ट आई होप कि आप लोगों को समझ आ गई होगी. एनीवे, इफ यू डोंट गेट एनी क्वेश्चन, जस्ट put the question in the comments, or we can have a session at Zoom, live session at Zoom. I will let the timings up to you guys. You can decide the timings. CR can text me, CR can tell me on WhatsApp. But please, CR, please send the message directly to me. Don't put it in the group that your coordinator has created, because that group is bombarded with so many messages that I can't find the relevant messages of me. In fact, I have put that group on silent for at least 6 months. So the next thing in continuation would be the AC voltmeter. Okay, before going to AC voltmeter, what's the conclusion here? The conclusion is that we can use op-amp as voltmeter, and the range can be selected by selecting the value of RS here, and with you can simply put R1 and RF equal to same value. You can usually get R1 is equal to RF, but we will always tend to get more higher values of R1. And why is that? Because this R1 determines how much current would be taken from the source that we are measuring. Let's say we got a capacitor here, and how much current will be drawn from the capacitor during the measurement depends on the value of R1. So higher the R1 is better. And whereas the range, you can select the range with the help of RS. If you put RS equal to 10 ohms, you will be getting 1 by 10, means that 10 millivolts will lead you to 1 milliampere current, which is your maximum deflection current. So if you put 100 ohms, 100 millivolts will be leading to 1 milliampere current. If you put 1 kilo ohm, then 1000 millivolts means that 1 volt will lead you to 1 milliampere, means that now your full scale deflection will represent 1 volt. And obviously you can go for 10 kilovolts and 1 megavolts, whatever. So the selector switch there is what that selector switch basically is. You got a switch over here that can connect to various values of RF. These values are usually 10 ohm, 1 kilo ohm, 10 kilo ohm. I mean, by the factor of 10 they used to increase, so that the range increases from millivolt to volt, then tens of volt, then hundreds of volts. So that's how you can do it. And now the next thing is, how do we make AC voltmeter? The AC voltmeter is basically the same circle like this, except that this part over here, in fact we should say that the voltmeter is now something different. The whole thing remains the same. This voltmeter is now a bit different. In fact, now this galvanometer comes with a sort of built-in rectifier in it. Let me explain that to you. I am going to erase the rest of the circuit, and now you will be focusing only on this thing, that what's inside it. So the AC galvanometer sort, although it's not proper word to use AC galvanometer, there is no AC galvanometer. Anyway, the galvanometer that can use to measure AC current is in fact what we got here. I got two diodes. Instead of like in rectifier we used to get the both diodes in same direction. Now here we will be having both diodes in opposite direction, and here we will put the galvanometer, the conventional one. We'll put a capacitor here, we'll put a capacitor over here, and this is the wheel. So this is how you can say either this is the positive side and this is the negative side. Now what will be happening? During the positive input peak, when the input signal is positive, you will be getting a positive peak at the V0, or maybe negative peak at the V0. Alternating it, you will be getting a positive and then a negative and then negative and then positive. So when there is positive voltage around here, the current path would be, this diode will be reverse biased, this diode will be forward biased, and the current will go through this point here up till this point. And now from here it will have two options to go. One would be through this capacitor and down here, and the other path will go through this galvanometer, and from here downward, because this diode is off. So the part of the current will flow through the galvanometer in this direction. Now remember this direction, in this direction the current is flowing. When there comes the negative half cycle, this terminal becomes positive and this one becomes negative, and the current flows from here in two directions. One is right over here, and then from this to here, because this diode is now forward biased, whereas this diode is now reverse biased. And part of current flows from here in this direction and from this place to here through galvanometer and then back through this diode. So look at this thing, the direction of current through galvanometer is same during both cycles. Means that the galvanometer needle will deflect in same direction both of the times. When there is a positive pulse, it will deflect in that direction. When there is negative pulse, it will again deflect in that direction. It will not go in the opposite direction. One thing. So what you will be getting? You will be getting the needle to be deflecting with positive and negative pulse. How to eliminate that thing? Because if it's continuously deflecting, you won't be able to read some constant value. So what we do here is we put a capacitor parallel to this galvanometer. Let me clean it a bit. this